Hi guys. How was your weekend? Let's see.
It was good. How was yours?
It was good, thank you. Anybody watch the Super Bowl?
Yes.
Do we like that the Bucks won?
Yes.
Love it.
Yes.
Yes.
Not a very eventful game though, right? I thought it would be more exciting. I don't
It
know.
was a good defensive game. Very just like the defense was good.
Yeah. It was
For my
good.
opinion, it was very underwhelming. I expected it to be, more pizzazz.
Yeah, I agree. Man, Brady, I mean, he's just amazing. You can't fault him. I mean, the guy is just phenomenally good. And think about it, he's almost 20 years older than what's his name? Mahan? What's his name?
Mahomes.
Mahomes.
Yeah, Mahomes, yeah. Almost 20 years older. I mean, he's still got it. You got to give it to him. And I'm not a huge Brady fan because I love the Ravens and, all that deflate gate thing and all of that with the New England team, New England Patriots, right? Yeah. Anyway, I totally agree. I think the Super Bowl was kind of underwhelming. And even that some of the commercials were cool. But even the halftime entertainment, I'm sorry, but I don't even know who that group was. Do you guys even know?
The Weeknd.
Yeah,
It was good. I liked it.
Yeah, maybe I need to listen to more of their music.
Shakira.
Yeah, I don't know. I guess I'm just getting old. I'm showing my age when I don't like the Super Bowl show. Anyway, all right. Well, I hope you all had a good weekend. I certainly did. It was very productive. One of those weekends where you just get so much stuff done, and then you just reward yourself with good food and fun times with friends. It was a good weekend. Okay, so we're gonna go. Actually, I think I might go a little bit out of order from the notes because as I was looking over, this is where we left off with section 1.7. And thank you to you guys that were texting me to remind me to open up the homework for longer. I really appreciate you doing that. And I don't mind at all if you text me because I get it faster and then I can change it for everybody that much faster. So thank you for that. All right, so I'm going to just kind of talk through this.
Professor, I have a quick question.
Yeah, go ahead.
How long is it open till?
What did I open it until? I don't remember. I think tomorrow maybe?
It
Last
said
night.
online that it was open until midnight last night.
Oh, was it midnight last night? Well, that doesn't work, does it? Because I haven't finished teaching it to you.
Yeah,
Yeah.
I was gonna.
I was
ask about
confused by that.
Yeah, it was really confusing.
I must have been looking. You know what I do sometimes is I look at like the month of, January, the thing, and then I'm looking at the dates and I'm like, okay, that seems fair to put it that date. So.
Wait, I have a question.
I'm sorry, guys. You must think I'm such a dork. All right, look at this big note.
I have a question.
Riley, yeah, go for it.
Are you gonna open it up for longer again?
Yeah.
All right, because there was a couple I had to skip and but I can do them now that they'll be opened.
Yeah, I guarantee you, I probably was looking at January's, on my phone, like January's, and I was looking at the days and saying, okay, this date is okay, so that date makes sense. I was probably just looking at the wrong month. Sorry, but big note, change Wiley. I'm gonna put it right here.
Thank you.
You're welcome. And let's see if it's tonight. Let's say make it due like tomorrow midnight. Does that seem fair? 2/8, 2/10.
That's
2/10, 2/10 tomorrow midnight. No, so that would be 2/9. All righty. Okay, so first I just want to talk over this doubling example because I have a half-life example that I'd like to do next, and then I'll do some financial stuff. So I'm not sure why I put it in this order. So we know that we have this formula for continuous growth, right? And we'd set it up like this, and then they say, what is the half-life of ozone? And we use this little trick that we start out with our continuous formula, and we just take 1/2 of the initial, right? Since this is the initial, what is it? The initial what? Initial quantity of ozone right here. Then if we say we want to know when this continuous formula is equal to 1/2 of what it was initially. So we can just use this little trick, and we use this because we can cancel out the initial value here and here. And then what happens is we're just left really with one variable, right? And then we take the log of both sides, and we know that once we have this situation, we end up getting just the exponent equal to ln of 1/2, which is just a number, and then divide both sides to solve for t. So the next example I want to do, I'm going to skip over example 4. I can bring this one back up. We're going to come back to that. And or maybe actually, I'm wrong. I can do example 4 first. I didn't realize that it all relates to itself anyway. So yeah, we'll do that. I was thinking that we should put it right next to a doubling, but we have to know this other stuff first before we can go to that. Okay, so a bank advertises an interest rate of 2% per year. If you deposit 10,000, how much is in the account after 4 years? If the interest rate is compounded first annually and then continuously. So we have an annual formula and a continuous formula. The continuous formula is the same one we've been using, right? So annually we've got P equals initial value times 1 plus R to the T power. We're just going to plug in what we know. The initial value is 10,000. And the rate is 2%. So the R is 0.02. So 1 plus R would be 1.02. And we're talking 4 years. So you just plug and chug, right? So you're going to get a value for that 10,824. So just straight into the formula. All right, and then we're just going to do the same thing for continuous formula. So P is equal to P sub 0 e to the RT formula. Just plug in what we know. P sub 0 is still 10,000. Rate is still 0.02. and that is raised to the 4th power. So you just put all of that in and you will get a different amount. So it makes sense that the second amount is higher because if something is continuously, what is it? Yeah, yeah. If your interest is continuously being compounded, you're going to make more money, right? Than if it's just compounded once a year. Okay, so now let's put this together with the whole double and half-life idea. Any questions so far? Okay. Okay, this time if 10,000 is deposited in an account paying interest at a rate of 1.5% per year, compounded continuously, how long does it take for the balance in the account to reach $12,000? So we're continuously, so we're going to use the continuous formula. P is equal to P sub 0 E RT. Let's see, we know this is the rate. We know this is what P is going to end up being. So 12,000 would go here. 10,000 they said is deposited, so that's our initial amount. Rate is 1.5%, which as a decimal is 0.015 T. And notice that the question here is asking us, how long does it take for the balance in the account to reach that? So we're talking about T, right? And we know all the other variables except for T. So we're just going to simplify the equation. The first thing we do, anybody know? What should we do first to solve this equation?
Isolate.
Go ahead, Dylan.
Subtract the 10,000 from the one side and bring it to the other.
Well, not subtract. You're on the right track. We're not going to subtract it though. It's being multiplied by the e to the.
So divide it.
Yeah, exactly. Good job. Yeah. So we're going to divide both sides by 10,000. So you'll get 1.2 is equal to e to the 0.015 t. What's the next step?
Take the natural log of both sides.
Yeah, thank you. We're going to do natural log of 1.2 equals the natural log of e to the 0.015 t. And remember, this e is implied, and whenever we have this, we get to use that shortcut that says that this just becomes whatever the exponent is. So now all of that simplifies to 0.015 t. Okay, so now what do we do? Got to get t by itself now, right? So we're just going to divide, right? So let's say you get 12.15 years, and let's say Wiley is saying round to the nearest 10th. What are you going to put? And then on Wiley, it's going to have blank years. What are you going to put in the blank?
Be 12.2.
Thank you. So be careful about what you put in your answers for Wiley. I mean, that may seem like a stupid question for me to ask you, but if you don't put it in as they're asking you to round it, it's just, they're gonna mark it wrong, right? Because they're expecting 12 point and a 2, not a 12.1 and a 5, right? So careful on that. Okay, so now what we're going to do is we're going to calculate the doubling time. How long does it take to double for interest rates of 1%, 2%, and 3% per year? So let's just do 1%, and then I'll kind of give you the summary of what actually happens. So we've got and compounded annually. So we're going to use this formula, P equals P sub 0 1 plus R to the T power. And we're going to plug in, no, actually what we're interested in here, just like we kind of were when we did that half life problem, what we're interested in is when is the initial value going to be twice as much as the initial value when it was, right? And let's see, we're doing 1% right now, so 1 plus 0.01 to the T power. So what can we do now? We've done this sort of thing before. What can we do? What's the little trick that I can do now to make fewer variables in my equation?
You could get rid of the initial values.
Yeah, whenever you have the same thing on both sides of the equation, you get to get rid of it, right? Assuming it's multiplication anyway. Okay, so we got rid of that. So now we just have 2 is equal to, we can simplify this to 1.01 to the T power. Then take the natural log of both sides. Let's see, let me do it up here. And then from there, I can use the expansion rule and bring this T down in front. So T natural log of 1.01 is equal to the natural log of 2. And now I want to get T by itself. So what should I do?
Would you divide both sides by the natural log of 1.01?
Yeah, nicely said. All right, and so you put that in your calculator, you're going to get 69.6. So let's say you put $20,000 in at 1%. It's going to take almost 70 years for the 20,000 to become 40,000, right? There's a pattern that will happen, right? If we did this same problem for 2%, we would get T is equal to 35 years. Oops. And if we did it at 3%, we would get T is equal to 23 years. All right, so let's put this together in kind of a table format, make it a little more organized answers, just so you can look at these answers. So 1%, if anything really invested at 1% is going to take, we got 69.6 years, right? 2%, if we did the same work that we just did, it would take 35 years, a lot less, right, to double. And 3%, it would take like 23.45. So this is what we call the rule of 70, right? To compute the approximate doubling time of an investment, all you really have to do is divide the interest rate by 70. So notice that 70 divided by 1% is about 70 years, right? So notice that 70 divided by 2% gives you how long? 35, right? And we did this doing our using our formula, but bankers use it all the time, right? So notice that 70 divided by 3 would give you about 23.3 years. So they do this quickly in their head, like how long would it take you to double your money? Let's divide your interest rate by 70. And you're always dividing by the same number. You will always be dividing by 70. Okay, there is a last page to your notes here, future value. But we're going to get rid of this because this is not part of your curriculum. It's on the, it's not applied calculus. It's the other calculus book. So I put this on here by mistake. So I'm getting rid of this. Go. All right, I will print that to a PDF later. All right, so now we're going to do a section that I think you guys will like because it's not very difficult and you've been exposed to it from Algebra 2 before. I like to put this section with the other sections because this is kind of the easy one and the other two are not so easy that come afterwards. So I'd like to throw in an easy one with some of the harder ones. This is one of the easy ones. Okay, compositions of functions. So back in Algebra 1, we studied linear functions, you know, y equals mx plus b, and exponential functions back in Algebra 2, and even the logarithm function, you know, I teach that in my college algebra class. In this section, we're going to learn how to create new functions by composing, stretching functions, shifting functions that we already are familiar with. Okay, so let's talk about composing functions. If you were to take two separate functions, you're going to let one function f of t be equal to the expression t squared. And you're going to let another function, g of t, right, be equal to t plus 2. So if I'm asking you using, you know, for this example, I want you to use f of t and g of t, you know, if I'm asking you to tell me what f of t plus 1 is, what I'm asking you to do is put, sorry, let me grab it. There. Is to put t plus 1 inside the function f. Okay, well, what is function f? Function f is something being squared, right? So what I want you to do is put t plus 1 into that. So t plus 1 is going to go in the function f, which is the function f is to take something t and square it. And then you could simplify this further by foiling it. Oops, not xt. or you could use a shortcut, whatever you guys like to do. So you get t squared plus 2t plus 1. So this, remember, this function notation is saying, here it's saying find f of t plus 1. So when you're answering it, you would say, well, f of t plus 1 is equal to, and here's what you're going to type into Wiley. This next example is telling you to take f, whatever f of t is, whatever that is, and add 3 to it. So let's see, what is f of t? F of t, so I can say f of t plus 3 equals, well, what's f of t? F of t is t squared, and then just add 3 to it. So here is your answer. So f of t plus 3 is equal to t squared plus 3. This next one is asking you to put t plus h inside the function f, okay? So you can say f of t plus h is equal to, let's see, let's scroll up here so we can see, well, let me just remind you just so it's close by, f of t equals t squared and g of t equals t plus 2. Okay, so we want to put whatever the variable is, we want to put t plus h wherever the variable is in function f, which is t squared. You're taking something and squaring it wherever the t is. So that means t plus h is going in there and you're going to square it. And if you were to FOIL that, t plus h and t plus h, you'll get t squared plus 2th plus h squared. Now, when you're doing a function inside a function like this is, so this you read this like find f of g of t. So what you want to do first is you always want to find the innermost and then plug that into the outermost. So if you look at g of t is t plus 2. So we want to put t plus 2 inside f. So f of t plus 2 would be t plus 2 quantity, since f is t squared. So then you just, if you FOIL this out, pay attention to Wiley if they ask you to simplify or not. Sometimes they do, sometimes they don't. And if they ask you to simplify, that's when you're going to FOIL it out. You have t squared plus what? 4t plus 4. And then the opposite, now we're going to start out by finding the innermost parentheses. So first, let's find what f of t is. F of t is t squared. So now we're going to put t squared inside g. So g of t squared is equal to, well, g is, back up here again, t plus 2. So we're going to put, where am I? Put f inside g. So that is t squared, g of t squared is t squared plus 2. Because g is just the variable and adding 2. So we're putting our t squared in for the variable and adding 2. We're doing okay so far, guys? that make sense? Some people are still writing. I'll give you a minute. All right, here's another composition of function. So this is just saying put G inside F. So if we put G, which is 5x plus 1, inside F. Uh-oh. G is 5x plus 1. So this means just put 5x plus 1 in F. So F of 5x plus 1 is equal to F is e to the x power. So that would be e to the 5x plus 1 power. And you're done. Any questions?
Yeah, can you give me 1 second as I write it down
Yeah,
before you
sure.
move? Thank you.
Mhm. Okay, here this means put F inside G. So F is e to the x. So G of e to the x, this just means put e to the x inside G. So the function G is 5x plus 1. So G of e to the x is equal to, let's see, the function G is 5x plus 1, so it would be 5 e to the x plus 1. So you're putting e to the x in where you see the variable in the G function, and you're done. All right, this next example, I just need, they do it on 1 or 2 of the homework problems. So I need to explain it. It's a lot easier than it seems. So think about if there's the word when x equals, then f of x will equal that. So when x is equal to 0, that means when you put 0 into f of x, you get an output of a 3. Okay, or when x is equal to 0, then g of x's output is 0. So let's answer these questions. So first it says find g of f of 0. Okay, so that means we need to find f of 0 first, right? So f of 0 is here. So when x is 0, f of 0 is 3. So what we want to do is find what g of 3 is, since we want g of f of 0. So when X is 3, right here, when X is 3, for G, you're going to get a 6 out. So the answer to this whole thing is f of G of f of 0 is going to equal 6. Let's do another one in color. Okay, what about if we're trying to find f of G of 0? Well, first let's find G of 0. G of 0, so when X is 0, G's output is 0. So now we want G of 0. So no, sorry, not G, F of 0. So this means when X is 0, f of X is going to give you 3. Let's try f of G of 1. So G of 1 means when X is 1, the output from G would be 2. So we want to now find f of 2. So when X is 2, F's output is -1. So that's the answer to f of G of 1. And finally, G of f of 1. First, we'll find f of 1. When X is 1, the output for f of X is 1. So that means we want to find G of 1. So when X is 1, go to the G output. G output is 2. So there's your final answer. I guess if you think about it, like this is the output. Right? And this is your input. And it's kind of, if you think about it, like f of X, remember how that's like Y? And G of X is just another variable that acts a lot like Y. And they're both input and outputs. Okay. Now this, we're going to get to this U substitution later on when we're doing differentiation and integration. And it's called U substitution. And basically all you're doing is you're making a problem easier to solve by kind of making it a simpler equation. So first thing you realize here is that there's an outside function and there's an inside function, right? So the outside function, oops, let's make this legible. Is taking the lag time. Uh-oh. Did it black out for you just now? Oh, I guess it just got stuck. Is taking the natural log. Boy, it's weird. Taking the natural log of something. So that's the outside function, kind of like, you know, if I had g of f of x, this would be the g part. So that would be that taking the ln of something is the outside function. And 3t is the inside. So all you have to do is just replace the inside with the letter u. That's why it's called u substitution. And then describe what u is. And we do this substitution so that we can solve an outside problem and then stick the inside part of it back into the outside problem, kind of like we're doing with composite functions. And we'll do more of that when we get to integration. So that's the answer here, to use a new variable u for the inside function to express each of the following as a composite function. And there's different ways you could do this really, but I would say that 2r plus 3 is the inside function, right? So you could say that w is equal to 5u squared with u equal to 2r plus 3. And here, what do you guys think is the inside function here?
Is it the negative 0.03t?
Yeah, it is. That's definitely what's inside the function, right? So here's inside. So we're just going to say p is equal to e to the u with u equal to negative 0.03. T, sorry, forgot the T. Any questions? Pretty basic, right? Okay, now we're going to move on to looking at transformation of graphs. And this is basically back from algebra 2, right? If you have like a regular parabola y equals x squared, this is the parent, this is what they call the parent function for quadratics, right? And you add for outside of the function, right? It's not in the thing being squared. That's what we call outside. Outside is vertical movement. If, on the other hand, notice that this is the original parent function, y equals x squared. And what we're doing is we're seeing something happening inside the function. You're going to get horizontal movement. And you get horizontal movement in the opposite direction you would think. Because look, if this is, the black graph is the original graph, and x minus 2 shifts it in really the opposite direction you would think, right? So think inside will shift it horizontally in the opposite direction as the sign. So we could say that if you had y equals the quantity x plus 2 squared, that you would expect to get a parabola that was moved to the left. That's a terrible shape. That was moved to the left. So vertical movement is, I like to tell my algebra students, it's straight up, right? Horizontal movement, you know, you can't really trust it. It goes the opposite direction that you think it would. But vertical, I could also add something in here like y is equal to x squared minus 4. And that graph would be shifted down. So vertical does what you think it would to the graph, where horizontal does the opposite. And you know it's horizontal if it's inside the function as opposed to outside the function. So let's see what does that mean for real life. Here's an example. Here's a cost function for a company. Fixed costs increased by $1,000. Sketch the graph of the new cost function. So if, let's see, yeah, let's say fixed costs were like rent, salaries. We'll get more into these kinds of things later, like BG&E, right? Power, you know, that kind of thing. The fixed cost is always what I like to say, and I said this before when we talked about linear graphs. This is the initial amount, initial value, or vertical intercept. So you just, if you wanted to see what C of Q looked like, it would be C of Q plus 1,000 on the outside. So what's going to happen is your graph is going to raise by 1,000. And this represents a vertical shift. Now, what would look like something that's on the inside is the next example. So here's a supply curve for a product. A new factory opens and produces 100 units of the product, no matter what the price. So sketch the graph of the new supply curve. So what we have here is we have C of Q minus 100. And what happens here is this is a horizontal shift. So it goes from where it is here. It's kind of hard to tell. Let's see. If it's minus 100, it's going to move to the right, not to the left. So this graph right here, I think I can do this. Maybe not. Oh, yeah, I can. Is going to move horizontally 100 units. And this is going to be off. The scale is going to be off. But just so you can see that I just took the graph and moved it to the right, 100 units. I'm going to say this was 100, just so you can see it. Otherwise, it's going to be hard to see that it's moved to the right by 100. Okay, and those are very, very basic examples. We're going to get into more detail in the coming chapters, but the Wiley problems will be simple also. All right, guys, we're going to end early today. That's all I have for you. Somebody asked me to meet with them today. Who was that? Wait, I have it written down. Sophia.
Yeah, it was me.
Okay, good. And can you tell everybody, since we have extra time, what questions you're going to ask? Because maybe some of these people have the same questions.
Well, I didn't realize, like, my homework said it was due last Thursday. That's why I was having problems, because I didn't know the
information. Oh, you know what? Before we do anything else, let me change that right now before I get off the line.
I was just guessing. That's why I was having trouble, but
Same here.
my homework said it was due last Thursday, so I just put in random information because I didn't know what else to do.
Oh, I'm sorry. That must have been that must have been really stressful.
Yeah.
I am sorry if I do that. You guys, if you're feeling that, I want you to text me and say, this is stressing me out, Miss Alderman, help me out. And I will. Okay. So let me go to Wiley right now and change it. And then you can ask any questions you want. Okay. All right. So let's go to Wiley. Okay, so can you guys open Wiley and make sure that it's opening for you? It says it's active here.
Yeah, it changed.
Awesome.
Professor, I'm just wondering, like, I haven't been able to find the recordings for the class on Moodle. I'm just wondering if you are posting them, because that would really help me.
Yeah, I can't post it on Moodle because there's not enough space. So what I have to do is, what I have done is created an external YouTube, and it's of YouTube channel. And so I'm going to post it on there. So I still have to grab that link. I'm going to grab that link after we're done here, and I'll put it on the Moodle site so that you can get right to the recordings. Thank you, Philippe. I did get
That would be great help. Thank you.
yeah. I did get your message, and I'm sorry. It's complicated, and it's very time consuming setting all this up. So I thought I could just upload it to Moodle, but it's too much, there's too much space. I'm happy to do that for you, Philippe. I promise I'll do that today. Anybody else have anything else for me? Sophia, what do you want to do? Some problems together? What do you want to do?
Well, I think I am probably good now because it was just because I didn't know what I was doing on the homework. But now,
Okay, so I have a suggestion then. How about you use this time to work on it, right? Since we have a little extra time, use this time to work on it and text me if you want to go over a problem.
Okay, perfect.
And then
Thank you.
I'll just hop back on, okay?
Can I like redo the problems then? Like, will they still be open to redo?
Yeah, I think, don't you get 3 attempts?
Okay, yeah, that's right. Okay.
Yeah, you get 3 attempts. Yeah.
Okay, thank you.
Janelle, you have a question, sweetie?
No, I answered it already.
Oh, okay. Anybody else have anything else for me? Don't hesitate to ask questions. Those of you that have met with me have found that you can clear up your confusion real quick, a couple questions. And so it's in and out. It's not like if we meet together, we have to be online for half an hour. Okay. And I'm happy to answer your questions. And I like doing it.
I had one question. Some of the questions on the homework, I used up like my 3 attempts. Like, will it give me more because
no,
it got
Sean,
extended or no?
No, it will not. 3 is the max.
Oh.
And unfortunately, that's one of those things that I can't go in and change.
Okay.
Once I've assigned it to just to be fair to everybody,
Okay.
All right.
All right.
Any other questions? All right, just text me if you need me, okay? If you just want to jump on real quick and I'm available, I will do that. All right? Okay. Have a good one, you guys.
Thank you.
Thank you.
Thank you.
Thank you. See ya.